All right, so if they are like terms, then we're going to combine them. Use the distributive property to add or subtract like terms. So when they say use the distributive property, what we're going to do is use the distributive property backwards. So we are going to undistribute. So I have 12 A's plus 37 A's. So the A and the A are the same. It is in common. So I'm going to pull out what they have in common. So it's like they went to see Oprah and they both got A's. And I'm going to say, well, hold up. Let's pull those A's out to the side. That's what you all got. And let's just frame what you are without the A's. So I have 12 plus 37. And then the times A there. So I took both of their times A's and put it up front, so it's in common. I undid the Oprah, everybody gets one. Now I have 12 plus 37 in the parentheses, which I can simplify. So 12 and 37 is 49. So this becomes 49 times A, which we just smush 49A. That is a whole lot to write when you're combining like terms. But if you're not used to it, if it's something that you've often like confused in the past, this can really help kind of like focus you in on what's going on, what can I do here? And then the undistributing is not bad practice, being able to see these terms as they're being multiplied, but there's stuff in common I can pull out or I can put back. All right, so here I have 16 xy's minus 51 xy's. So I say them like they're a thing, a label, like they get a little tss on the end to say it's multiple things. Just, I'm used to reading it that way, and it helps people remember, like, are these like terms? Am I saying 16 apples minus 51 apples, or was I saying 16 apples minus 51 equals? These are apples and apples, xy and xy. So the in-between, use the distributive property, would look like 16 minus 51, and then with the xy smushed there, 16 minus 51, so 41 minus 6, 35, negative 35, xy. So we are combining the things that have the same exact variable. All right, now down here on C, I'm mixing it up some. We've got more than one variable in our term. So it has to be the same exact label. Everybody's got to have, each letter may have an exponent. If it does, then that exponent with the letter has to match across the terms. Meaning, if I was doing my Oprah effect and I'm going to factor out what everybody got, they all have to have gotten the same thing. Now, it is possible, sometimes like on Ellen, everybody got a thing, but then she picks a person to play a game and they got an extra thing that other people didn't. You only pull out what they all can give back. Even though one person got some extra special prize, it's just the what did everybody get? Let's pull that out. So here I have 102 m squared n minus 97 m squared n. So m squared n, those are exactly the same. M squared is m times m, and then an n. So same variables. So we're going to pull those out to the side. So I got 102 here, minus 97, and everybody got m squared n. So 102 minus 97 is 5. So that is 5 m squared n. Now, if you go look at other YouTube videos or like Khan Academy or something, unless they are talking about combining like terms, they will skip that in between parentheses step. And they'll just say, okay, I got 102 m squared n, the other one's m squared n, these are like terms, and then they'll just crunch the numbers and then write the variables exactly the same afterwards. All right, now over here on D, things get a little more interesting, only a little. So 7z's minus 8z's plus z. Okay, so everybody has a z. I'm going to undistribute, factor, and pull that z out. So when I do that, I have 7 minus 8. Now it is very tempting to stop there because the other one, well, I pulled the z out, so it's not there anymore. But I want you to look at this. If I multiplied, if I distributed the z back through, I would have 7z minus 8z. But that's not what I started with. So I'm missing something here. That's why there's still space. So I need a placeholder there. So remember, this is coming out at 7 times z, negative 8 times z. So what number can I multiply z by and still have it be z? And that number is, of course, 1. So we can think of this single z being added here as 1z. That's even how, we'd say it. So this is going to have plus 1 as that placeholder. And now that is what we can crunch. So 7 minus 8 is negative 1. Plus 1 is 0. So 0 times z, we don't even have to write the z. That is 0. Because whatever value z is, it's still going to be 0. That is the mighty power of the 0. Now, good Lord, do we have terms? Okay, so we're going to look for the things that are the same, and we're going to crunch those numbers together and keep the label that they got. Then look for other things that are the same, crunch them together, keep the label, if they have one. So I have negative 17, that is just a constant. If there are any other just constants, just numbers being added or subtracted here, then I can combine them. Anytime we say combining like terms, it's with addition and subtraction. Multiplication, division do crazy things, but combining is always about adding and subtracting. All right, so negative 17, then I have minus 45x plus 71x minus 29x plus 9, no x. Those guys are like. So negative 17 plus 9 leaves us with 8 negatives left over. So those two combine to be negative 8. Now, some people will put like boxes around one set of like terms and then circles around another and triangles around another. Like there's a number of ways to visually classify these, and by all means, do that if it helps you. All right, so now we have a negative 45x plus 71x and minus 29x or plus negative 29x. So those three are like terms. So I need to crunch the numbers in front, very similar to what happened on D, but I'm going to skip the parentheses step. So negative 45 plus 71 minus 29. You could just crunch that on the calculator. I am too tired. I'm going to crunch that on the typing calculator. Negative 49 plus 71 minus 29 equals negative 7. Okay. So those all reduce down to negative 7x's. So there's more negatives than there were positive. That is it. Both of those together. Negative 8 minus 7x, or you could write negative 7x minus 8. All right. Now we go looking for more like terms on F. Now, this is kind of interesting. So here, I'm not looking at what can I pull out from everybody. Like in the first couple ones, we had two terms, they were like, so I pulled out what they had in common to show you that the numbers are going to crunch together and we can combine them. So here, I've got 28 xy's minus 7 just y's minus 83 xy's. So 2 of those are like terms, 1 of them is not. So the unlike term, we're just going to get in our answer. It has nothing else to combine with. But our like terms here, the negative 28xy's minus 83xy's, those can be combined. So 28 minus 83, it's 5 and 5. Negative 55 xy. And then again, that negative 7y, there's nothing to combine it with, so we just copy it down. Minus 7y. Now, both terms do have that y in common, and I could factor that out if I needed to. And there are times where that is actually a useful step. It would look weird right now, but there are other times where factoring out that y actually allows us to do an extra step. Like do more. It looks crazy, but we'll actually end up with a result we want. All right. So let's pause those, then we'll come back for the next set.